So I'll start with today's agenda. So what we'll try to cover, yesterday we started with the introduction of system design and about the design types and what to expect in design interview. And we'll continue that discussion. And so in today's agenda, first thing we'll discuss the foundation of design. Okay, and we'll cover basically not foundation, I'll say fundamentals of design. So what are the basic tenets of any system? Basically, we'll try to categorize so that it's easy to break down the any problem which is presented as part of system design interviews. So you would have a clear understanding what are different tenets which are needed to start with the design. And second thing, the interview framework. Okay. So in this section, we'll talk about basically what are the techniques basically you can use and how you utilize your time of that 45 minutes so that you cover all the expectations started from requirement gathering till your design is working end to end. This is similar to like when you are solving a DS problem. So at the end, you have to run the test cases. So similarly in design also, what are the steps we can take to navigate the discussion. Okay. Then we'll talk about basically we'll start with the OOPS concept. So we'll move into low level design and we'll talk about OOPS concepts. Okay. And if time permits, we can take further this object oriented analysis and we can start with the solid principles. Okay. All right. So let's get started with the fundamentals of design. When it comes to designing a system, right? So there are some parameters or some areas basically that we need to cover, and there are some building blocks basically. So using those, we can say like our system is ready for use. Okay. So what are those areas? Can anyone volunteer and just talk about like what are those key areas that key components basically that form a system?
Databases,
storage,
yeah, storage, databases.
Okay.
network,
Okay.
Programming language, choice of programming language or choice of databases which are using.
Yeah.
Right.
All right. Yeah. These are all valid answers. So basically, for any design, there are 4 things we need. Some first thing is like foundation. Okay. So there is some foundation on that we do build our system. We'll talk in a while about the foundation. So first thing is the foundation of system, and second parameter is basically characteristics. And third important pillar for any system are basically components. And fourth point is basically the tech stack. All right. So when we say like foundation, what is foundation for any system? So for foundation for any system, whether it's a desktop application or it's a web application or any microservice or any sort of application. So you have application running on your desktop and it requires a basic foundation, basically what characteristics it offers. Okay. So what are those things? Basically, we have a client. Okay. Client can be anything, mobile device. Okay. Um, or a web browser. Okay, there can be a website using which, or you can have a exe if it is a Windows application that is running on your machine. So that is a thin client basically that provides an interface to your customers using which they can um, submit their requests, for example filling a form or calling a command, like from command line you run a command, but that runs in background basically. Yeah.
Components, tech
Yeah.
stack, components.
Your voice is echoing. Yeah, Mohsin.
Yeah, oh, okay. I'll just mute it maybe. There's some network problem.
Okay, all right. Okay, so we'll talk about all of them. So first thing is the foundation for any systems are client and server. Okay, so without client and server, no system can be completed. So the server could be same machine, like on same machine there is some backend logic that is running, and there is a client which is sending the request, and when the request is fulfilled, the response is sent. So basically there is this request response format that is for HTTP applications where we have request response method. But if you see in a nutshell, any application or any form, whether it's a desktop application, console application, or any web application, mobile application, so basically this is a foundation. Without this you cannot complete. So for end user at very abstract level, we can think of what is foundation. So in foundation we have client and server. Okay, so foundation contains as client and server. Basically these two things are needed to fulfill any requirement for customer, and that is a bare minimum for any system. Then coming to, once we have this foundation, right, then
Pramod,
there are
batch things will come on which side? I mean, batch is also one type of client.
batch is one type of client. Okay, batch job you are talking about.
Yeah, somewhat batch processing.
Yes, so batch processing, like you are having some modular line of code or commands that do execute, and they do some computation or some processing, and then they give you result. So the command you are typing, for example run batch.exe, right, so that is your client code. That is a abstracted form using which you interact with your system. So that is
So
your client.
yeah, that comes also in client, right?
Yeah, the command is part of client. Okay, that is client. Okay, after that whatever computation or anything that is happening using some logic, so that may be running on same machine, but basically that compute power we can say that is part of server. So server is doing, so your batch job, maybe you want to run that batch job across multiple machines, right? So those are the servers, the responsibility for computation or doing any calculation, that is part of your server. So we said like that is a foundation for any system. So like to build a system, first thing we need a client and a server. Then what type of client is this, what is the scope of that client, and what is required to build this server, right? So there are some certain, every system has a foundation, then every system has some characteristics. Okay, so what are those characteristics? Basically are the objectives that they are fulfilling and how they are doing, right? So the foundation, you can think of this is what part, and then there is a how part. Okay, so in characteristics, what we can say, few characteristics would be like availability. For few systems, we need those systems to be highly available. Okay. And this availability is most critical thing for me. Whenever I am sending a request to system, I don't want a error message, but I want a response. So whatever data is present, so we'll talk more about those cap theorem, consistency, availability, and partition tolerance later session. But for now, the availability is basically the system should be always available. So any system, when we say we have a client and server, but when client sends a request to server, the system should be available. It should not send me error like system is down. So that is one of the characteristics. It depends on nature of the system and process we are doing, but availability is one of the critical parameter or characteristics of the system. Then reliability. Okay, so the system should be reliable. Whenever we are giving some command, each time it should give me the similar computation it should do. It should not apply any different logic for some set of computation that it was meant for. So if I send request like what is the output of 3 plus 2, each time it should give me 5 only. That is a reliability. So we do trust. And if we talk about the larger system, bigger system, so nowadays reliability is measured into number of pipes. So sometimes they say 3 pipes. Okay. So what does 3.5 means? 3.5 reliability, 3.9 reliability. So 3.9 reliability is basically your system has an error rate of 0.001. Okay, out of thousands requests, you can say 4.9 or 5.9 based on that. So many like services, they do guarantee like 5.9 is my reliability, and that is very rare. But still, like the error rate through dashboards, whenever you are monitoring, you see like each time my system is honoring a request, whether this is a REST system or any system, there could be network failures or there could be server down, but actually the end customers should not get error until maybe we will retry or whatever we do, we make an arrangement of design. We talked about design. So what is design? Like that arrangement of systems and components and services, how we arrange and how we make them available always, so that the reliability is like critical piece for me. So this is another characteristic. System should be available, the system should be reliable, and it should also be consistent, right? So consistent. Okay, so consistency is another key. So for example, if you take a database sort of system, and when you start a transaction and complete the transaction, maybe you can roll back the transaction, but after completing those set of commands or instructions, the system should remain in consistent state. It should not break the consistency. So, for example, if you take a database system and you have 4 tables, so either it should insert or modify the records what it was meant for in all 4 tables, or none of them. So for example, if you are inserting the records and writing a stored procedure that should insert records in 4 tables, that then I say my transaction is completed. But for example, it completed in 2 tables and then it failed. So that is not a consistency, right? So before and after the transaction, your system should remain consistent. So that is another characteristics of the system. Okay, and then comes the throughput. So there is a high throughput that is expected from any system. So when you are sending request, it has some SQ defined, and it is meant to like process 1,000 requests per second, or it can support 100,000 users. So it should actually honor those many requests. It should give that throughput, and the system should be always available, and it should be honoring all those throughput requirements. So these are few of the characteristics, not limited. There can be many characteristics of the system. So when we say we have a foundation of a system, in foundation we have a client server. In this client server combination, they should have some characteristics like availability, reliability, consistency, throughput, or any other characteristics. You can add many more. Any other characteristics you guys want to talk about? What are other characteristics of a system?
I think scalability is important one.
Okay. Yeah. Yeah, that's a good one. Scalability. Yeah, system should be scalable.
And operations, I think some company call it site reliability engineering. It has probably to do with a lot of different things, maybe like operations. You mentioned telemetry in the first session.
Right. Yeah. Yeah. Yeah, that's right. So now we understand the essence of characteristics, right? If we have,
Pramod,
yeah.
hello.
Go ahead. Yeah, go ahead.
Cost efficient will be also considered as a characteristic. Cost efficient means when we are preparing the pipeline, whatever it is, so the cost is the major factor. Because of this, the design is getting rejected. So can we consider that part also?
Exactly. Yes. So like based on the requirement, each system, maybe some system has a availability high requirement. Other system may have consistency requirement. So for example, there is a financial OLTP type of transaction is happening. So you may have noticed like banks websites. So sometimes they do take downtime, right? So when they are rolling up major update to their system, maybe there is an acquisition and bank want to merge into another system, and that time they cannot afford consistency, right? Because there is a financials involved in that, so they may say consistency is my top requirement. And maybe other system, for example Facebook or any social media, availability is my requirement. So maybe my friend has posted update 1 hour back, so that is coming to my feed, but maybe something which was sent 5 seconds back that has not refreshed, so it is not impacting anything, so that's fine, like I can afford that. So it depends on nature of the system. So cost, yes, maybe there you are coming with a customer requirement which says like this is my budget, under this you have to build a system, so many technologies, you can use so many servers and you can make system highly available, consistent, reliable, you can meet all those parameters. But along with these requirements, I have a budget constraint also. So that is also a characteristics of the system. So those factors which are impacting your like functional, non-functional requirements basically, and those are characteristics of any system. All right. So yes, so it depends. So now basically what we are trying to say, like the system has these 4 parts when we say foundation, characteristics, components, and tech stack. So why we are talking these areas? Because whenever we are going to design any system from scratch in our day-to-day professional work, or we are going to interview, we should cover these areas. Basically, these are the bare bones for any complete system design. Okay, so you should think about the foundation, and when you are framing your assumptions about the requirement, you keep these points in mind so that you don't miss anything, right? So that's why broadly we are categorizing. So essentially the foundation, like client and server model, is always there, and that client server model should have some characteristics, not limited to these. There can be many, but these are the top characteristics that any system should basically facilitate or provide. Okay. Now coming back to components. Okay. Components. So what are the system components basically? Anybody?
Storage network.
Okay.
Data.
Docker.
Okay.
Cloud.
So we say cloud. Okay.
Running environment.
Yeah. So running environment, you say, for example, yeah, running environment is like basically a web server or like operating system or basically a machine configuration, right? So, but like components basically where your services basically get hosted. Okay, and what are the requirements for that system requirement? For example, if you are installing a Windows on your machine, so we'll say like these are the requirements which are needed for my machine, your client, to run this system. But in backend, like this system will have something like it requires an operating system. Okay, it requires a web server where you are hosting from where the requests are being served to customers. So web server is nothing, a machine, a physical machine sitting somewhere, but it is connected to network so that all the requests are going to that machine, and from there response are computed and returned. So if we start from the beginning, like in system design, so how you start, like DNS is one thing. Okay, you need a DNS, domain name server. You need some load balancers, right? You need load balancers, and you need databases. Uh, what else? So you need cache, right?
Message queues.
Message queues, okay, or you can say queues, okay. CDNs,
Proxies.
or you
What
can
is
say rate limiters.
what is CDN?
CDN is content delivery network. In few of the sessions, we'll cover that in detail. So in what situation you should use a CDN to serve the content to your customer when you are designing a system. So for now, you can think of a content delivery network. So for example, whenever you are downloading some files or softwares or movies, those are basically stored in a cache near to your location, and through different CDNs like Akamai, or there is China Cache. There are many basically. Even AWS provides some cache CDNs, and Azure, GCP, all of them provide CDNs. Okay, so these are next
What
thing.
are rate limiters?
Rate limiters, like you can define how many requests basically your server can honor or process. So there is always a limit for each system. So for example, if you are attaching a file to your WhatsApp, right? So can you attach a file of 1 terabyte there? No, right? It will say maximum 5 GB. So 5 GB is maximum limit you can attach. So that 5 GB is a limit. So there should be some hardware or software that sits on your server, and it keeps monitoring the payload and requests. It is not only size, it is number of requests also. So for example, your system can process only 1,000 requests per second, and maybe someone is trying to hack your site. So there is this what do you say, DDoS attack, right? Have you heard DDoS attack? Anybody?
Yeah.
What
Yes.
is that?
Means the attacker tries to
Denial of service attack.
yeah.
Okay, yeah. So for example, that is used in warfare. If you see in Ukraine, Russia itself, so people are trying to hack the servers of their enemies. So what they do basically, DDoS is basically faking a request. So for example, if you have a financial system and I run a compute like number of servers, and in parallel thread, they can bombard your system with so much load so that those are invalid requests, and they take your system overwhelms with these requests. And the genuine users, suppose I have a banking SBI website, and someone sends so many DDoS requests, so that the actual users may be impacted. They will see the server is down, requests are getting down. So those are DDoS attacks. Okay, so yeah. So rate limiter is basically to avoid these attacks. So they should basically, there should be a way defined on your server where like it can there are different strategies how you handle those requests. So if you are getting, for example, some from same IP address, you are getting more than 500 requests, you can like stop those requests sending to your internal of the system from outside layer itself. Or there are some logic like you can have some queues to park those messages in queue, and there are some approaches like leaky bucket and all those things. We'll talk in those sessions. So rate limiter also will talk these CDNs, rate limiter, queues, cache, databases, load balancer. All these topics we'll discuss in detail in upcoming session. I'm just setting some foundation for now. So
Pramod,
if you
sorry to interrupt. Should be you mentioned the WhatsApp example, right? So applications which stores unstructured files such as image or a PDF file. Probably they also need a blob or file storage system.
Correct.
Right?
Yeah. Yes. Yeah. Definitely. Yeah. So that storage is expensive, right? So if someone is attaching so many files, so you need to stop the request which your system cannot handle, or like implement some strategy how you are basically taking those requests, and there would be some latency, and what is your SLA, for example, right? So after retries and all, how much time it will take to complete those requests. So rate limiter is basically, as the name suggests, it is limiting the rate of requests which are coming to your system. Okay.
I was saying that can we add file storage as a component? That's what I was trying to suggest.
File storage, yeah, file storage is a, so you can say storage basically. Yeah, storage is also a component. What type of storage we'll talk in a while. So these are components basically which builds the system. How these things are related. So build a system, you need a client server, set of client and servers at abstracted level, but these client server combination will have some characteristics, basically reliability, availability, all these characteristics, how you meet these characteristics, right? So if I want to ensure high availability, right, or I want to have this reliability, then what I will need, maybe I need set of load balancers, I need a CDN, because each time if there is a concurrency on same file, there are thousands of people who are trying to download the same file. There may be some lock, right? Your file can go in the state it is not responding. So what you can do, you can make the multiple copies of that file, and you can put that behind the load balancer, so that request which can be some fulfilled by one instance are routed accordingly, right? So that is like availability and consistency, reliability requirements. So these are the requirements. How they are fulfilled? They are fulfilled using these components. Basically, these are type of components. It's also again not limited. There can be many more. Okay, but essentially now you understand what are the components which are needed to meet the characteristics, right? Then fourth thing
Ramu,
comes.
what
Yeah.
kind of programming language we are selecting that comes in component or text stack?
That comes in text stack. Okay, so tech stack. Now you said web server. So web server can be of any type, right? So the Apache or Windows, IS, right? Or operating systems. You have different operating systems which are there, or domain name system resolver. There are also again types like provided by your ISPs or your like service provider, and some are having cache in your machine. There are load balancers, so software hardware load balancers are there. There are databases, right? So SQL, NoSQL, all type of databases are there. So but in to meet these characteristics, basically using these components, what is the granular level tech stack that is better for this? So if for example you are using queues, whether service bus queue, what ecosystem you are. If you are in Azure, you may be using service bus topic. If you are in any other cloud, maybe you are using other queuing mechanism, right? So Kafka can be used, and CDNs. So like what CDNs are supported in your country, and what is the cost? That is another factor. So which CDN is, whether you need a CDN or not. If you need a CDN, what type of content you are storing there. So for example, if you are building e-commerce website and it has lots of images and videos which doesn't change for each request or frequently or not changing, so maybe you can put those data in CDN. So there are multiple providers, like you can go to Akamai or Verizon or any other CDN, right? So which CDN suits your requirement? Basically, that the name of that tech stack basically is the fourth part. So basically, to what type of component are there? So tech stack is nothing but just to identify the part of the component. So you can say like IIS is my web server. Okay. So for example, just I'm thinking loud. Okay. You say Oracle is your database, so IIS. Okay, or you can say Redis cache is your cache choice of cache mechanism, right? You can say Kubernetes, okay, it is your microservices orchestrator. You can say like some app services. Like when you are going in that design interview, you considered, you think about like this is client server. I'm designing a chat messenger, so I will need a mobile client and I need a server that is fulfilling the request. Then what are the characteristics I talked about? Yeah, this is most important thing for me. Then how I achieved. So further to drill down your that client and servers, you can use these components you initially described: a storage, a rate limiter, a CDN, a queue, a cache. Combining all these, you built your system. Then further, like your technology choices, what type of CDN you should be using, all that comes in the tech stack. So you can justify your tech stack if you are choosing the SQL, and depending on the nature of data, you can say this requires relational database structure, so I would use Oracle or NoSQL or SQL Server, okay, Postgre, any type of database. And then you come to other things, right? So is this clear, guys? Does it make sense thinking about these fundamentals of any system? Or you want to share your thoughts
Yeah,
with respect to
Pramod, design patterns are comes under components. Can we include design patterns?
Components? What we can include?
Design patterns. So like we have a lot of proxies and all. We have like single
Design patterns.
Yeah.
So design patterns, no, those are not basically a component or under which you host something or run something. Those are ways of writing code. So I mentioned here app services, right? So if you are building a system, so these are, when I say Oracle, right? This is a database. So what it is a software, right? It is a already written software that you don't need to design a code or write a code how the query data is stored, how is fetched. So basically they provide that abstraction. You use some keys. So these are the software, but you can write your services basically. So while writing your service, you are writing an e-commerce site and you need to design the order processing service. So maybe you ended up designing a microservice, and there you are using different factory pattern or whatever pattern that you are implementing. So that is part of tech stack. So using C# or Java or Python, Delphi, whatever language you are using that language while writing your code, you use some design patterns. So design patterns are not a hardware or software. They are just standard practices. They can be written in any language. Those are the technology agnostic things, right? So it is not part of.
Yeah, promote. Say I am building an application and I am in a dilemma to use the cloud infrastructure, maybe GCP, Azure, or AWS. So these, the choice of the cloud services that should come under components or tech stack.
Yeah, so if you are using cloud, that can be a component. Okay, so if you are using a cloud computing, so you can say that is a component. But what cloud? You said GCP, right? Or it's not like GCP offers a number of features. Maybe in GCP you are using Postgre, for example. So they do offer like on top of this Postgre, maybe they are offering the zero redundancy and built-in maintenance you don't need to install on your machines. So this comes in tech stack. So like in tech GCP, this cloud, I will use this feature. So that is my tech stack. But what is the component? Component is obviously cloud computing or cloud serverless architects. So that is a component.
Got it.
Okay. All right. So yeah, so these are the things. So moving to our next topic, which is basically design interview framework. Okay. Would say system design. Okay, so this I want to talk about because we'll cover slowly. We'll move into depth of all other topics, but um, we have a mixed sort of audience. I know many folks are already in senior position and they have attended the system design interviews, and few of them might be in a situation they are just still preparing and curious about what is expected in those design interviews and how I should approach to that problem. And maybe you have an upcoming interview in days before this course is completed. So let's not wait for that. I would share some like high level things like what is expected in design interviews and how you can structure your answers about answering those questions. Okay, so basically, yeah, I have written 2 points before moving into that. Yesterday we talked about, just to rephrase what we discussed yesterday. So what is evaluated in these interviews basically is like we discussed these points. I'm just to refresh that. So the ability to collaborate and communicate, that is evaluated, and to work under pressure, like in 45 minutes, how you accomplish so many features and talk about them. So that is accomplished asking these sort of questions. So how you work under pressure and how you resolve the ambiguity constructively. So if one liner requirement is given to you, how do you come up with the clear requirements and MVPs out of that ambiguous statement? That is also evaluated. Okay, and this is very important thing, basically the ability to ask the question. So many people are tempted to, they maybe your interviewer hasn't done his prep work before the interview and he is tempted to ask a very common question. Maybe he asks you to design a parking lot, and there is lot of material available on internet, and you have already mugged up the design and you just started solving that problem because you know what he's asking and it's very clear. But this is very critical part to asking the good questions, and that is essential skill for any design interview. So before jumping into solution, you should ask the questions and have a consensus or have an agreement like what you are going to solve, what part of that feature you are going to solve, and how to respond to these questions basically. So you can keep in mind these points. Demonstrate your design skills. So you know multiple things, you know lots of design patterns, you know lots of tech stacks. Okay, then you demonstrate through design, you demonstrate your design skills to answer those questions. And multiple times we discussed like no answer is right or wrong, no solution is correct or incorrect. Only thing is whatever you are thinking or sharing, you should know the reasoning behind that. And also it's not a final design. So suppose you proposed, I want to implement a CDN, or I want to use a cache, a local cache. So like either can be used, but you should go gradually. Like I'm thinking I'll use the cache and I'll store this data from the database on regular interval, and that would be my cache expiration policy. So I will define some TTL, then it will expire. Then you say, okay, I think maybe having a cache, and when the service is scaled up and there are the customers from across the globe, so my cache may not suffice to fulfill all those requirements. So maybe we need to like part of data, some static data that I am seeing, I can put that data in a CD. So that is a gradually you are improvising your solution. So that should be part of your design choice. Like whatever design you are taking, you are going step by step and defending that. Okay, and respond to feedback constructively, right? So whenever your interviewer is sharing some feedback and he thinks actually this is not a correct choice, maybe he's trying to help you, and there can be trap also, he want to deviate you also, so you are getting influence. So be very clever and very clear in those situations. Basically, you understand if he's giving a wrong solution, you can question like, I think in this approach there could be these problems. So according to me, that can be wrong, but it should not appear rude or something. But yeah, responding to those feedbacks in constructive manner or positive. You need to be assertive, not aggressive. Okay. And avoid over engineering. So whenever you are solving any problem, maybe you know advanced technologies and techniques, okay, and highly scalable system, but you should know whether what is the main characteristic of the system, right? So that's why we talked about characteristics before this. So depending on the nature of the system, avoid over engineering. Okay. All right. So having said that, how we can break down our solution into steps. So every system design interview is different. Okay, and all those interviews are open-ended, and there is no one size fit for everything, right? So we talked about like there can be differences, but still there are some common ground. Okay, common patterns in each design pattern, each design interview. So we should keep we can like divide into few blocks, or we can break down that answer or that solution into few parts. So the first thing is to understand the requirement. Okay. and define the scope. When a question is presented to you, the first thing you should do is to understand the requirement, like what is the requirement. So how you do that? You ask question. So like you would have seen in your class or any group learning sessions. So maybe there are few students which are favorite to teachers also. And why they are favorite? Because they do help teachers to navigate through the lectures by answering all those questions. So suppose new topic is started and the teacher asked a question. There are 2-3 guys in every class. They will be like attempting to answer each question, whether they know or not know, right or wrong, but they quickly answer that, and they become the favorite of teachers because they are always proactive, or they are listening and supporting. So those who answer those questions quickly, they get rewarded. Or if you see, there is a fastest finger first, right? So the person who answers first is a winner. But that thing doesn't apply to your design interview. You don't get a brownie point of by solving that question quicker. Okay. So unlike the problem solving or DS question, so you are given 40 minutes, and in that you have to solve 2 lead code medium questions, and you are doing very fast. Interviewer is very impressed. That doesn't apply in system design. It doesn't mean you need to be very slow, but yes, before coming to any solution, first spend few minutes at least. So I would say like how to break down your time. 5 minutes. Sometimes maybe that could be very ambiguous problem. Okay, so 5 to 10 minutes to ask questions and define a scope. What could be those questions? Basically, what are the questions that one should ask? Okay, so if I ask you to design for example e-commerce website which allows users to place the order and track their orders. What would be the questions you would ask me if I am giving this much requirement only?
Who all are the end users of the system?
Okay. For the end users, okay. Yeah, that's a good question.
What should be the client interface? Whether it's only web-based or mobile app?
Say that again.
The client interface, whether it should be.
Okay. So whether it would be a website or mobile application, right? Or
Yeah.
it is device specific. Yeah, that is a good question to ask. Like because based on that, you will answer some questions like what technology choices you are going to make and how it will run. So that is very critical question to ask. Whether it is a desktop application, maybe I want to deploy this in my organization only. I'm working in a department and I want to distribute some gifts and I want to set up e-commerce for my employees. They can order the choice of goodies that I'm offering, right? So yeah, that's another good question to ask. And what other things?
The number of
Whether it will
requests.
whether it will have an admin panel separately or like for uploading the products and everything.
Assumptions about existing dependent features, right? So those can be like I assume already I have a admin panel who can onboard the products which are listed on my e-commerce site, right? So yes, so those are dependent features. So we can not specific, but you can talk about 3-4 features. Like these features are basically inbuilt, and I am assuming these are inbuilt, and I don't need to focus on them, and I'll build on top of that. So these are the questions. So basically, yes. Apart from this, you need to talk about functional requirements, NFRs, and estimation, basically estimates. So yeah, we discussed what are the functional requirement, where we talk the MVPs and non-functional requirement, where we do talk about these characteristics of the system, like what is the availability, reliability requirement. Okay, and in functional requirement you ask like there is a user who can place an order, there is a user who can track his order, user can make a payment. All those are the functional requirements, and then there are non-functional requirements. At a time 100,000 active users can place an order, and this would be globally available system, so persons living in any part of world, they can use the systems. All those non-functional requirements are also computed, and the estimates, basically how much database it would be needed. So if I say 100 million active users and one user has his profile data and they are using maybe 1 MB space to have their profile and everything, and then what would be the total size that would be needed in a year, you can say. So you can compute by like dividing by number of users and the number of days in a year. So basically a rough estimate, so that you have an idea whenever you are deciding a database or the number of instances that would be running. So a quick estimate. Okay? It's not like, and not to be accurate like these many users are there. So quick estimate also you share. It shows your thought process. You are thinking deeper about end solutions. So in first 5 to 10 minutes.
Pramod, can we say here like what kind of external APIs we can use, like anything like for example Google Map, or somewhere about we are using the pin code service because we are designing that kind of. So can we ask that kind of a
Yeah.
question as well?
Yes, yes. So suppose you are building a cab booking system, and that booking system requires the map data, okay? Or you are building a food delivery site that requires maps data, and maps data maybe we are assuming like we will leverage some inbuilt APIs. Okay, so I think someone was, Arashi, you were saying something?
Using the external APIs.
Yeah, using the external APIs, right? Yeah, so like if you are building, suppose a food delivery site, so the question is asked about to build that. Yes, you can share that in your assumptions. I would be using Google API, and maybe I'll be storing that map data in my cache, so that each time if there is no network for a rider, they may the navigation doesn't impact, right? So those are actually intelligent questions that you can share as assumptions, like, yes, I would be using that, not building. So that is, so you define the scope and out of scope. So that is also important. So scope and out of scope. So for example, building this map system is out of scope. I'll leverage some APIs, and it should not, again, like I said, it's not like you give a quick answer. So what I mean is, like, it's not you start just drawing a system or designing a component, but at least 5 to 10 minutes, 10-minute max. Okay, don't spend too much time discussing about the requirements only, because you won't be left with the time. If it is a 45-minute questions, so it means you would be left with 30 minutes for maybe it's a low level design, so writing the code or designing the tech stack, because that requires more drill down and detailed discussion, deeper discussion. Okay, I am getting some noise from Mukesh, I think. You're saying something, Mukesh? Okay, all right.
No.
Okay, all right. No worries. Okay, yeah. So there was a question in chat, like, can we talk about third-party libraries and pet services? Yes, we can talk about those that will be used. Or you can, if you know that, you can talk about those in your next section itself. But like for requirement clarification, scoping in, scoping out the things, functional, non-functional requirements, quick estimates, all this should not take more than 10 minutes. So try to wrap up this discussion 5 to 10 minutes. Okay. Uh, okay. So next is propose HLD. Okay. So high level design and move ahead. Okay. So why this is needed? So just to reconfirm the flow of system and actors. Okay, so for example, we were talking about this website. So you can think about, like, you can just say, so I'm assuming there is a customer, okay, and he will send a request to say my this e-commerce site, and this e-commerce site will store the user's data and everything in DB, and after that it will persist the data somewhere, and then it will send a response back to customer. So this is very high level. I'm just talking abstract. You can depict 2-3 more components if there are multi-parts. So this was a customer, maybe there is a seller also, so you can say there is a seller basically who is providing the material, and that material is stored in using a API or using an interface. That data is also persisted in database. When user comes, they do using this portal, they do search and they get the result. So that is a high level, like proposal. So just take 2 to 3 minutes to draw this high level design, so that you are clear with the whatever assumptions you made, whatever requirement you understood in this section. You just reconfirm your understanding diagrammatically. So whatever you are talking so far, just draw that, so that you are getting a buy-in from your interviewer, and to move forward. If he says yes, this is the correct approach, and let's go into deeper design. or there may be some suggestions, some feedbacks. We talk about taking the feedbacks constructively. So if you are getting a feedback, you missed one more requirement. There is another person, there is an admin also who needs to validate the seller's products. They cannot upload anything. There should be a proofreading, and the seller should provide some metadata also, right? So that metadata needs to be stored in some temporary storage. So like that. So there could be some iterations that you should be ready to understand. So you know high level flow of the systems, and now you go to design. The third step is any questions so far? We are good, right? You are following?
Yes, Pramod.
Okay. Okay. Now deep dive. Components. Okay. So we talked about the components. So what are the components?
Pramod, one point here. Hello.
Yeah, go ahead.
Say the step second, when you propose the high level design. So the
Yeah.
interviewer, we will have a positive note from him, right? Okay. Once he will approve a sort of in the interview itself that yes, this is the way design, then only we can go into the deep dive. Maybe he can suggest changes in the high level design itself, right?
Yeah. So there could be one or two liners. Like if you missed some other, maybe while collecting the requirement, you talked about many things, right? Some scope and out of scope thing. So maybe you are missing some requirements, or you can have a use case diagram rather than this. You can have a use case diagram. You can say this is the user. User can create the profile. User can these four to five features like use cases we talk about, right? So you say u1 u2, these are my use cases that user can do. So basically yes, you in this you just talk about those things and get a confirmation from your interviewer. So based on the feedback, basically you can modify also and just move into deep dive in the components, like what components are needed. So this is very brief, like not should not take 1 to 2 minutes basically. Okay.
Promotes, for example, if we miss some functionality in on this HLD diagram or use case diagram, will be a
No,
negative impact on interview, that I have
no,
missed.
no. There won't be any negative impact. It would be good, in fact, like, because rather than you can go to step 3 directly, but if you have gone too far from there, you cannot revert with this time, right? So maybe you went into design, and for example you were doing some LLD and you are writing code and you designed the classes and properties and you wrote that method. Then your interviewer said, see, this was not discussed and this is not the requirement. I'm not worried about that feature. Maybe you are focusing too much on DB transactions. I was too focused on how you will scale up this service instance for my global customers, right? So it's better that is positive, not negative against you if you miss something, right? So that shows the mindset, the probing, like how you are growing gradually and building on step by step, not just giving a perfect solution. Okay, and this is how you do in your real-time work also, right? So suppose
Right.
you are in a team, and in sprint planning, a new piece of code has to be decided. Then you start writing some assumptions, and you said, yes, these are the test cases that should pass once I write this functionality. Then someone you are discussing with, they suggested, no, you are missing this, or you did over engineering. This was not needed. Already, this feature is built in some other system. You could have borrowed from there, right?
Yeah.
All right, yeah. So coming to next point, that is deep dive into components. So what you cover in this section, like deep dive, identify the priorities. Okay. So here, like you identify the priorities and think about how NFRs are met. So when I identify the priorities, so for example, I talked about this e-commerce site, and now you know, like I have service. So when a customer sends a request, there is a authentication layer. Okay, there is a authentication service, and then my order processing service is there. And users are coming from different locations, so my order processing service has a single point of failure, so I need to have multiple instances. If I have this horizontal scaling for number of instances, then I need some load balancers and some routing logic. Okay, so maybe I give a suggestion about using a API gateway, and I decided this order processing service, and this order processing service depends on a payment service, so I will write a payment service, and payment service depends on a gateway, payment gateway service. Okay, so those are 4 5 services that I will need, and these services would be built using this technology stack. Maybe I'll be using a serverless compute in cloud, or I would be writing some console applications which are listening to some queue. Basically, once order is placed, and then there is a confirmation service which confirms the customer your order has been placed and payment is successful. Now you can go to tracking. All those components basically you identify, and based on priority you design in what set of databases, cache, CDNs, how you will arrange, how those components will interact. Basically you break down this e-com service into those sections. This is just an example for the sake of example I'm talking. And then once you have done, then and you are also talking keeping in mind how the NFRs are made. So like for high availability and reliability or consistency, you are using this SQL database or no SQL database. All those components basically are designed. So you said between user, there is a load balancer, okay, and user sent a request to load balancer. This load balancer distributes to different services. So this is service 1, this is service 2. Okay, it routes traffic to like this. Then there is another load balancer that is sitting internal for database operations. Okay, so these load balancer routes the traffic to say DB1, DB2. Okay, so these are my databases to which this load balancer is sending the traffic. And then I have another service that is for read. Okay, and then like this service S3 basically reads from nearest database, and it sends the response to the server. So this is a deep dive. Basically, you broke down your service into multiple pieces, and you then talk about. So this is your part. And another important thing, like try to lead these discussions. Like many times we are tempted to ask so many questions. So for example, if you ask, there is a notification service, and this notification service works on this, and maybe you are not very confident about the tech stack that is being used to process the real-time data, right? So don't go into that direction. Take your direction into the area which is your strongest area. Maybe you don't know too much about load balancer, so just talk in one line. Do not give too much weightage to that. Or you are not very efficient in database, then stick to the service performance and how transactions are happening, how you are handling the fallback, what how you avoid the single point of failure, all those things basically. So you should lead that discussion. If you ask too many questions like should I use this also, then interviewer will usually say yes. Okay, so like in that way you are going deeper into, like he's leading the discussions, and you are going out of your control. All right, so yeah, the third part is like deep dive into the components. And the fourth part would be to conclude this design basically. Okay, so basically what is a that is a wrap up closure.
Pramod, if the requirement comes on single line, so which design, I mean, we will give more aspect to LLD or HLD?
No, you ask that question. So what is expected in your conversation itself? Whether we want like code for that. So maybe if it is a low level design, your interview will say, this is my requirement, and I want to uh, identify the classes, entities, and their relationships. Okay,
So that
so that
interviewers will say us that
yeah, he'll,
concentrate
he'll tell
more
you.
on.
Yeah, you ask that. So there are two approaches. So let me cover this point, then we'll come to that. So wrap up and closure. So like you design this system, right? Whatever flow it was asked. So ensure like meeting uh, the MVPs and working E to E, end to end basically. So like if there was a requirement like seller should be able to publish the product information, metadata, and the product catalog, and users should be able to search and place an order. So your diagram should depict both the parties. It's not only you stuck to user flow only, like user will send the request, this will come this way, and so other part is not completed, right? So it is not working end to end. So maybe for from other side of your system you need you need a seller basically. So basically seller is sending some data, and that data is placed in some queue, and then and the service S4 is running, which is reading from this queue and persisting in this database. So now you established like this is my sorry, this is not a database. Okay, in this database. Okay, so now you establish like there is this database where metadata was created, and using that user was sending a request, and he was able to read the data which was published by publisher, and now the same data is rendered to end customer. Okay, so that way this design is complete. Now you can say like this is how the flow is working, and your interview will ask to talk about any area. Sometimes they will give you freedom, like take let's dig deeper upon one of the components, because all of them you cannot go deeper. So they may want to understand your knowledge of CDNs, your knowledge of caches, your knowledge of database partitioning, sharding, how you elect a leader in database maintenance. Maybe in DB has multiple instances, it's not single DB is there. So first all read requests are coming to this database, then there is a replication so that data is consistent across the databases. So maybe that discussion can go 5-10 minutes. Discussion goes into that direction. Okay, so in this area you spend around 20 minutes. In 20 minutes you design end-to-end flow and talk, and remaining 5 minutes you have for this wrap up and closure. And in wrap up and closure you talk about the flow, like how end-to-end this system is working, and how you are meeting those non-functional requirements. So non-functional requirements basically you proactively should talk about if there is a flash sale going on my e-commerce website, so I'm expecting this much load based on the data available. So I will have like number of backup services that are running, okay, for that period of time, and after that I'll take them down, or I can write a monitoring service that monitors the queues. If load is increasing, it will alert us, or it will spin up new instances, so that all those loads are like fulfilled with respect to the non-functional requirements. All right. So these are the 4 points basically. Using like these areas and managing your time, you could answer any design questions. And it's not like if based on your current existing knowledge you can crack any interview. It's not like you need to just complete a course only and waiting for that. So if you keep these points in mind, you can navigate through easily in any interview. All right. Any
Pramod,
questions?
one
Yeah.
question I have. Do we have to give the tech stack as well here? Like, for example, we are talking about e-commerce. So can we use Magento e-commerce or OpenCart e-commerce?
Magento e-commerce and OpenCart e-commerce are already built-in templates. So no,
Yeah.
interviewer is not asking you to use that. That is a configuration. You are not engineering that, right? You
Yes.
have to engineer a Magento, for example, here. And if you are engineering that Magento, so what are the components you are using? And yes, the other question you ask it very good, like this databases. So what I said DB only. So whether this is a SQL or no SQL. Once you design this, you just drill down like for user profile, I'll be using SQL, that is relational data, because I want to track the user login history, order history, and all that I'll keep in SQL database. And the transactions which are happening in the system, that I will keep in NoSQL. So if someone is searching their search history or any flash sale is going on, how a product is performing, all that information which is very high and that requires read only, I may be keeping that in NoSQL. And what NoSQL I will be using, maybe I will be using MongoDB or Cosmos DB, okay, or I'll be using Postgre, whatever database you think can fulfill the NFRs. Basically, you propose that. So apart from these components and these services, like this is a microservice one, this is a microservice two, or you can say just simply this is a synchronous API that is hosted in app server. And yeah, it is sufficient to fulfill that requirement. No need to do over engineering. So but what tech stack you are using, you can talk about, like this is a service written using Java and hosted in IS server. That is a tech stack. So mostly tech stack doesn't, like technology programming doesn't play a major role. Major role play by these like databases, like what type of database you are using, whether it's a SQL or no SQL, because whether you use Oracle or SQL Server, all of them offer the same type of SQL querying and processing capability, right? So maybe somewhere data warehouse sort of requirement is there, then you can propose some system database which has those features basically inbuilt. Okay, so you can use those type of database storage, but you should have a proper reasoning for whatever database you are proposing.
So we cannot use in the simple way, we cannot use the created one like Magento or OpenCart
Now,
or
those are so those are like already built-in
functional.
templates basically.
Yeah.
So there is no engineering needed. You just need to configure and run based on the instructions they have provided to set up and keep
Okay.
that running. Okay.
Thank you.
Yeah. Promote one more thing. Say the system design interviews are, means let's say we are from the data engineering part. So
Okay.
our system design interview will be related to the data engineering also, or it could be a generic one.
That is generic one actually. So you are coming from database or anywhere. So here nobody is asking you to write a code or anything. But and these design interviews are for the senior folks, mostly for architects. Yesterday we discussed, right? So maybe they will have 2-3 design interviews. And if you are going for DBM also or engineering manager, but you need to know, because you are a senior and you are responsible for overall feature, not only your feature, right? So how those components or services do interact to fulfill business requirement. So if it is a say healthcare system, in that healthcare they know there are the like labs or hospitals, those are the integral part of each other. So like hospitals or doctors who are working on that module, they will need test reports, and they do depend on those basically diagnosis services. So a person who is working as a database engineer, he should know like what all data they are storing. They are storing data from generated from all part of application, not only one part of application. And they have to prioritize like which part of that component has more critical business needs to have a data available in in real time, right? So according to that, you allocate more infrastructure, right? So you have to take that decision. So for setting up that vision and decision, you need to know the flow end to end. It's not like you are going to be working in one part of the system, but you don't know. So these interviews, basically, they're not asking real-time questions. They are asking some generic questions, overall engineering aspect, how the system works end to end.
Okay, yeah, got it.
Okay, all right. Any other questions? All right, so this was all about introduction to high level design, low level design, and what are differences, how you answer the interview questions. This was just to set a context how these sessions are going to be. I may be using some terms, maybe few of you haven't heard when we talk about these microservices, load balancers, CDNs, those many terms basically, and those are being used intentionally just to familiarize you with these. And going forward section, there are dedicated sections when we'll talk about these components. So just don't get overwhelmed or don't worry about like if you are not understanding. And I'm always open to answer those questions. If you find something is going over your head, you are not getting that, just raise your hand and ask that. I would be happy to answer that. Okay, so yes, we covered the introduction part and these sections. And if you have upcoming interview, just go through this session recording. Also, if you have any doubts, reach out to me, and I wish you all the luck if you have any upcoming interview in coming days. Okay, just go with fresh ideas and mindset. Let's move on to next topic. So I will start with for now we are moving to low level design specifically. Okay, in low level design we'll talk about start with the programming paradigms. So there are different type of programming paradigms, and object oriented programming is another programming paradigm. And when we talk about the system design, basically it is an object oriented system design only. Okay, but like why object oriented system design only, we need to understand what are different programming paradigms available. Okay, uh, yeah, so we'll talk about a few of them so that you understand why this object oriented is better than others, and why this is preferred by many people. So there are so basically what programming paradigm is, right? So anybody want to ask what a programming paradigm is?
So basically, it's the classification of the programming based on object-oriented functional programming.
But this is not specific to object-oriented. Programming paradigm is method to basically programming paradigm is a method to solve problems using programming language. Okay, so there are many programming languages available, and each programming language has a different type of syntax or different type of features to fulfill those requirements and programming styles. So when we think about any programming language, if I ask you to learn a new programming language, what are the few things that we learn, and how do we start? So we just start with the what are the primitive data types that are supported by that programming language. For example, int, okay, string, char, all those types, right? So string, maybe in some language you are saying str, in some language you will say where. Okay, in some language you will say integer is a keyword, in some language it will be int, and somewhere it would be in 32, in 64, and further classify how much space and what is the size of that integer value. So those are basically the data types. Once you know the data types, you know the operators, basically operations. So if you have to perform a concatenation to a string, there may be inbuilt concat methods, and there will be some like operators, basically plus, minus, subtraction, addition, those operators are there. You know those operators, then you move to preprocessor. So basically those preprocessors are compiler provided library. If you start with C, right? So stdio.h, those preprocessor, basically those are precompiled codes that are available, and using that you can use the inbuilt function. So there are primitive types, then there are custom types. So for example, arrays, okay, or there are the classes, objects. Those are the custom types. Basically, those are built on top of primitive types. Using a primitive type of string, you can create an array of strings. Okay, yeah, using the integer, you can create array of integer, right? So those are basic construct of the programming. Then comes the programming style. So some programming language have like if you go to DOS, that was also used as a command language. So you just write a command. You don't have a function declaration or method declaration. There is no modularity, right? You just write code each after command each after other, and it is doing something. Some work is being done. Some programming language provide the methods and signatures. They say this is a method and it will take a parameter. So those are the modular programming, and those are why they are helpful, because in that you have a reusability thing. Like if the same function, it depends on the parameter only. I supplied, I want simply to compute something. I want a sum of two numbers. So basically I said I will supply int, and it will give me an output of int. Basically it will do a sum. So inside that method you applied sum, and you said sum equal to for example, you passed a and b. So this become dynamically, you return a plus b. Okay, so that is a inbuilt method. For example, the language provides sum, and sum is a method that is already provided, and you just need to change. If you pass 3 plus 2, you will get 5. You add 1 plus 1, it will give you 2. So this is a modular, this is a reusable sort of thing. So few programming languages provide that feature, and few programming language just are the structure oriented. So step by step they provide you some features. And there are other programming languages. For example, you see about JAML, or you see this XML, right? So what are those languages? Those are, or HTML, for example. So those are declarative language. So you just declare something in form of tags, and they do provide some functionality, right? Okay, so now we understand what is the programming paradigm. Programming paradigm is a method to solve the problem using a programming language. Okay, so what are those different type of paradigms? One is imperative. Okay, so imperative paradigm, what it tells, um, like basically this is a way to solve it's step by step step by step task by changing the state. If you have any like the sequence, for example, first you need to load the data, then you transform the data, then you insert the data. Those are the steps which are available. So using those steps, basically this programming style, basically in this programming imperative style, you just step by step things are completed. Okay, so then other things comes the procedural language. So procedural programming language, basically they talk about the procedure or method. Method. So you have a set of methods. This we talked about. There we took an example, and they process top to bottom, and so whatever is written in that method, that will execute from top to bottom. And the benefit of procedural style of programming paradigm is basically that is reusable. So same method can be used used by different part of your code, just changing the parameters. And then comes the object oriented programming paradigm. So it depends on, basically it models the real world object into classes and objects. So like you abstract any real-time thing, you say a person, a human, okay, a person, you can say person is a class, and then person will have some characteristic. It will have height, weight, location, okay, and what are the features, it can walk, eat, talk, all those the functionalities basically that person can provide through the class. So class can be one blueprint, it has the set of properties basically and methods which work on those properties to give you the results. And one class can have multiple objects, so this is again reusable. So one blueprint you define, you now create a multiple instances or objects, okay. So those instances can have multiple properties. So depending on like one class, once you define, you can have multiple instances of that class, and each instance will have their own set of characteristics, own set of features, okay. Then there are this declarative language we just talk about, for example YAML or XML, where you declare the actions in that command. On load it will happen, it will do this processing. On close it will do this processing. Or you have like Windows form also, so on button click it you declare on click, like it will save the data to database. So those are the declarative style of programming language. And it's not a silver bullet or thumb rule, like one is preferred or other is preferred. There can be combination of those. So for example, this declarative and object oriented can be combined to create a very efficient mobile application, right? And then there are some logical programming languages, and logical basically are used for basically puzzles and games, okay. Are some examples to solve the puzzles and games. There are some logical programming language, like there are methods in which do some computation and provide some functionality to solve the puzzles and mathematical problems. And there are functional programming also. So functional is dedicated for mathematical. So you have R or other language where basically you get the power of this number, or compute the algebraic expression basically. So there are some programming language paradigms which are meant for solving those type of problems. And the last one is DB processing programming language. So in DB processing, basically you talk about SQL sort of transactions. You write a SQL statement, create, insert, delete, all those operations. So select star from this, that is another type of paradigm, or you can say SQL itself is a programming language. So using that you can run set of commands against your database to perform those CRUD operations on database. So these are the different programming paradigms, and they are meant for different things. But here we are interested in learning object-oriented programming, and why we want to learn this, and what are the key features. So basically, object-oriented programming, it provides you flexibility and reusability over other things. So like building a commercial applications or day-to-day they use, any system can be modeled around objects and classes. And this is basically flexible, reusable, and easy to understand, okay. So So object-oriented, if you talk about the real-time object and model them into classes and objects, basically you clearly understand, you can relate with the things. I took the person example. So you can think about like this person can do this thing, or if we take some real-time example, we were talking about this order processing service. So I can say there is a order service. That order service can have certain parameters. It requires the product name, product ID, maybe product image, and then it can have create order, delete order, update order. So these type of methods that can be defined. And once I define that order class, there can be different type of orders, and I can say apparel ordering service, or I can say electronics ordering service. So same class can be reused multiple times, right? So it is flexible, reusable, and very easy to understand. And that's why most of the systems, modern systems, they are built using object-oriented programming paradigm. Okay, so when we talk about the system design, basically it's object-oriented system design. And apart from that, this basically oops when so now let's talk about. So any question about these programming paradigms, guys, before I
Yeah, Pramod, I have one question. So you have, I mean, we have discussed a lot, many different paradigms, right? My understanding is some of these paradigms, like which programming language are you going to use to build your software, directly relates to your overall software design, such as like in case you are pulling up an OOPS language such as Java, it directly relates to the way you have to design your software, right? And some of these languages such as SQL, which doesn't exactly directly relate with your software design. You can have a software design based on OOPS, and you can still have a SQL layer where you can execute your queries, right? Is that understanding right?
yeah, that is. So I gave example, right? You can combine them. So like this XAML or this logical or functional even. So you are building a machine learning model, okay, and in that you are using R in backend. That model has been trained and all mathematical computation has happened in abstracted layer, and you need to provide an API using which customers can directly, without knowing the internal, they just can like use that system, right? So this object-oriented programming provides you a front-facing interface. Using that, you can build a system using other things, right?
Makes sense.
So
Thank you.
yeah. So it's not. That's why I talked about all of them. So the DB processing, where is DB processing needed? Maybe you are just on database engineer, and in backend you just need to transform, you perform some ETL operations, okay? And so what is ETL? ETL is basically extract, transform, and load data. So maybe your customers each day they are providing data in comma separated files, or you have some set of IoT devices which are emitting the data, and they can emit data in some text format only, okay? And that data needs to be presented to your customers at front end, okay? So maybe you write just a ETL service that points to extract the data from that flat file and transform that data. It attaches some columns, do some massaging to data, and gets out of 100 fields, 8 to 10 fields, and store them in a SQL, so that is a reusable. So this part only you were taking care of. So you are using only DB processing language, and that doesn't require any object-oriented thing, right? But if that data is stored in a table, and that table actually represents your customer data, basically it says like this is the data that is coming from these devices, and it gives me data about the customers, okay? And now I want to expose that data to customers in my front end layer. I want to search for a particular customer. So I need a object-oriented programming. I can model like this is a customer, and this customer has this data. So using the object-oriented programming language, I converted that uh, data into information. So we know, right, what is the difference between data and information. So data is raw. It is just raw data. It is a foundation or base, but it is not a meaningful. It is not giving me anything until I convert into information. So to convert into information, maybe I do some processing and attach it to some meaningful objects basically, and those objects are in usable format presented to our customers. All right. Did I answer your question?
Yes, yes. Thank you. Yeah.
Any other question, guys? So we are clear with the different programming paradigms, and we'll be talking about the OOPS, but it is good to know all those programming paradigms which are around there. We can take a whole session about talking about these programming language, their examples, and some code snippet. But that doesn't make sense for the purpose we are here. We just want to focus on these object-oriented programming language and what is the relation in what scenario you use. That we should know. That is the intent. Okay. So yeah. So object-oriented. So before moving forward, so object-oriented programming language are basically like we know they transform the real-world objects into the code by converting them into designing the blueprints like classes and objects. So we say like real-world things are converted into classes in objects, and these programming languages offer some features, and those are basically known as OOPS features. Okay, so what are those OOPS features? So we say we talked about reusability. So how is reusability supported by object-oriented programming language? So in object-oriented programming language, first thing comes encapsulation. Okay, then comes inheritance. Okay, and what else?
Abstraction.
Okay, yeah.
And polymorphism. Yeah.
Polymorphism. Yeah, I know you guys, all of you know this. Just setting some context and refresh our memories. What are these things? Okay, so like any object-oriented programming language offers these standard things which are applicable to the classes and objects. Okay, so before going into these details, so these are the features which are offered by any programming language. So there are a few other things like modifiers. So like when we talk about the class, so let's first talk about the class. So what class is, because all these features do depend on the class and objects. So when I say class, so class is basically blueprint, okay, which has attributes and basically operations performed on these attributes. So class is a custom, basically custom data type and blueprint which has attributes and operations performed on these attributes. Okay, so what does this mean? We talked about primitive types. Like any programming language supports some primitive types, like it's a int, char, or string, bool, right? So these are primitive data types Okay, and using these primitive types, we can say custom data types. So when I say custom data type, so that is class or structure, right? Class. So when we define a class, so class has these things. Basically, it will require some primitive types. Using that, a custom data type is built, which is known as class. Basically, it will encapsulate these things, and with some what you say, access modifiers, right? So there are some access modifiers. So it controls basically who can access those fields and how I want to expose that information to for implementation or for use in our code. So what are access modifiers, guys?
Public, private, protected, default.
Public, private. What is
Protected.
Okay, yeah. So these are lot of access modifiers that any programming language supports. But in like we talk about the OOPS, so basically class will have we talked about the class will have attributes, right? So these things, attributes and operations. So these operations, we say who can, so encapsulation is nothing but arranging these attributes and operations with access modifiers. So when we arrange these things together, it becomes a encapsulation. So for example, take example of a class. For example, we say class, okay, and I want to say this class is public. So anybody can create an instance of this class, and class is a keyword, okay, and this is the access modifier and a keyword, and then we say I say student, okay. For simplicity, let's take this, and then this class will have some primitive types basically, and we'll call them. So I can say in student ID, okay, and I can say get. When I say get set, it means we are defining this as a property. Okay, this is a property. This attribute, it is known as attribute property. Okay, in a class I can have a string student name. It has again getter and setters, and getter and setters are properties. So attributes and properties, and then methods. So I can say public get student. Yes, okay. Let's have one more property. Or I can say address student address, and I said get set. Okay. So yeah, we'll talk about this, and I have this method, and method takes parameter. In the student ID, and this will do some computation. Say I'll say some DB operation, okay, to get the student details, and return. And I say return okay. And yeah, let's talk about this structure, what this is. So I declared access modifier. It means this class can be accessed outside, like anybody can use this class. If I would have made this private, means it can not be instantiated from outside, and it is protected, means like within same namespace. If there are multiple classes that can be used within a scope, or we can say within a namespace that can be used, it is protected, but outside module it cannot be used. Then we come to these uh, basically properties or attributes. So I can say like this method is private, this property is private to this class only. And address, I said address, so maybe address is another class which contains the student address. It has a student ID and it has student city, house number, and all that information that can also be put in here with the properties. And then I have a method which operates on these parameters. So these parameters basically this class can use when I'm like getting or setting. I can say save student detail. So I want to save in database, so I don't want to expose this information to outside. I just want student ID basically, and using that I can compute other details and get the details from database. And for example, if I want to save, I can have another method. So this blueprint, this overall, it is known as a class. And if I want to instantiate this class, I would say student, let's say have a name, John equal to new student. Okay. Basically, so I created an instance of this class, and I said this student name is John, which is basically an instance of this class, and it can now this object. So when we created an instance, basically this is an object of this class. So student class has an object. Now when I have created an object, I can use all the properties which are public or methods which are public using this object. So because I made these things private, I cannot access using this. It will give me an error, but I can say get student. I can call get student, and it can give me, and like basically I said one, it can give me the details of that student, and I can store details like this. So this is syntax I'm just talking about, not very accurate, but just want to share the idea of the classes and objects in OOPS paradigm or object-oriented programming. So there is a concept of the classes and objects, and there are certain attributes, like we say attributes and operations, and so these are the attributes, and there is a operations, and then there are access modifiers, okay, and the custom data type. So basically class is a custom data type. It is using those set of basically primitive data types and doing some operations that we can define as a method name or operation name, okay, or procedure name. All are interchangeably used, and this class can be instantiated multiple times and reused, and it comes with certain features. So when we talk about what encapsulation is, so encapsulation is just a way of arranging these attributes and access modifiers and methods. So like basically we are wrapping around all those things together and giving it a name identifier that is a student. So now all the this is a feature of encapsulation, okay. And then comes this inheritance, okay. So when we talk about inheritance, inheritance is basically allowing the usability of the components in object-oriented programming language. So when we want to provide a relationship between between parent and child classes, okay. So when we created this class, for example, student class, and I want to use this student details in other classes also, which can have other methods. So for example, I said I have another class, public engineering student. Okay, and this class will have a new set of features basically. Okay, and but it needs to support this student get student detail from the class which we already defined. Okay, so if I use this column, it means inheritance in one of the programming language, but other programming language can have other keywords, like you can say extend keyword. Okay, so it extends, basically engineering student extends this class, and it is basically giving new methods and properties. So maybe this engineering student have public admission class, a public admission method, and I said string engineering branch. Okay, and this is again property. Okay, so just to give an example of this, so I have this method, for example, and it takes student ID as a input, and then it performs some operations for giving admission to a student in a particular engineering branch. So basically, when I create an instance of this engineering student class, it will have two methods. One method get student details, and other method admission. Okay, so basically it is inheriting reusing basically the attributes and methods from parent class. So inheritance is a way to provide a reusability and decoupling the code and providing the extensibility. So in design patterns, basically we use this a lot. If we want to provide some abstract methods or properties in a class, and I want these classes to inherit that, so that is known as inheritance. And inheritance is basically a way to provide the extensibility to parent class. All right, then comes the abstraction. So what abstraction is? Can someone volunteer? Okay, abstraction is a way to guys, just give me thumbs up if you are with me and I'm audible.
Yes, Pramod.
Yes.
Okay, okay, all right, okay. So yes, so abstraction is a way to abstract, okay, or basically hide certain details from basically not from details in swing essentials only. Okay, so how that is achieved and how it is different from inheritance. So in inheritance, basically we are allowing the child class to inherit everything from this class, but if we want to provide some generic sort of contract or generic properties that are useful, but I'm giving a flexibility to the child classes. So in this inheritance, here is a get student details method in student class. But if I have a class named engineering student, and this class want to give a new definition to this method, so here we were doing some DB operation returning the student information, but along with that the engineering uh, student class maybe giving the additional detail of engineering student branch, right, which is not there. So if I want to give this functionality to a child class, basically, so what we do, we use to declare a class, we use a keyword known as abstract keyword. Okay, and we provide some functionality, and there are like methods in, if I talk about Java or C#. So there is a virtual method, and I give that method as a virtual keyword. Okay, and it means it can be overridden and have a new implementation in the child class. So these are the two keywords which supports basically to give a new definition. So what we do, first thing, we say public abstract class, say vehicle. I took a vehicle class, and in this vehicle class, I can define public virtual vehicle type, for example. Okay, and or I would say same vehicle details. Okay, so this is the implementation, and here I can give some implementation basically that I can simply say console dot write, and I can say registered. Okay, and now this class I want to be inherited by some other classes. Basically, I would say yeah, I say I have a class named body. Okay, and this class basically inherits this vehicle class, and it needs its own implementation of this method, which is already declared here. So what we would do, we would say public override save class, and here I can give a new definition. I can say body registered, right? So when I create an instance of this Audi class and I call save vehicle method, actually it will print this one because this method has been overridden. But if I have not implemented this class at all here, and I have just inherited this class, and I called this Audi class dot save vehicle, it would print this one because this is a standard implementation that is provided. So abstract classes are a special type of classes which provide partial features, and they can have some methods that are internal. So I can write here private compute rate, for example, and I get some logic around this while writing this save vehicle, and I do not want to share that information with this class. Basically, when they create an instance, this method can be used indirectly, but hiding all those complexities within this, so that can also be achieved. Or I can have some public properties, those can be edits used by this class, or I can give a partial implementation, and remaining things, basically when I am inheriting this class, I have to implement this method. So another thing is like abstract classes also mandates if a method has been made virtual, and the inheriting class has to implement this, otherwise it will, while you compile, it will give you an error. Okay. So yes, so that is basically abstraction and polymorphisms all together. In we create abstract classes, or there are another concept like similar to classes. There are interfaces. So interfaces basically provides only signature. They do differ from abstract classes the way, like in interfaces you just give a signature like this shape vehicle, and you don't provide any implementation, but the class which is inheriting this, it has to provide its own definition. So that is basically a contract type of implementation. If you want to enforce some implementation across your classes, you can define an interface and ask those classes to use that interface and use those methods only to implement. Okay, so that's all from the basic OOP concepts. I know you all know that. I just wanted to refresh this and setting the context, because when we go to solid principles, we will see the detailed implementation. And when we go to design patterns, basically these concepts, classes, and this abstraction or inheritance are used. Without this, you cannot complete a single design pattern. So that was the idea, just to set a context about the design paradigms and object-oriented design definitions, and what are the key tenets of any object-oriented programming. So those are basically these objects and classes, access modifiers, okay, and these properties like characteristics like encapsulation, inheritance, abstraction, and polymorphism. Okay, so in next session we would go to further into this low-level design aspects. So we'll cover basically solid principles, then we will move to design patterns. But before that, we need to talk some more topics, basically UML that is needed for establishing the relationship. So we talk one type of relationship, okay, and UML notations. So in UML, basically we need to know the class diagrams, object diagrams, and how the classes and objects do interact. And there are certain relationships like aggregation, or there is a composition, right? So those relationships basically will talk about this next step of inheritance. And before moving to design patterns, I would like to cover the relationships and the notations. Basically, if you are designing a low-level system and there are multiple classes and one class depends on other class and it needs to inherit, so what type of relation is there, okay, and how that can be implemented, that would be our next topic of discussion. After that, we'll deep dive into design patterns.